For problem number 11, I'm told that this woodpecker is pecking at a 17-meter pole until the pole cracks and falls over. It hits the ground at a point 10 meters away from the foot of the pole. The upper part doesn't completely break off, and I want to know how high the woodpecker was above the ground at the time that he pecked through the pole. So let's take a look at this.
I'm going to look at the solution to the woodpecker problem. Here I have basically an image of what was happening. You have this pole that goes up. The woodpecker pecks away at the pole, and the pole breaks off and falls down in that direction. We're told that the pole is 17 feet long. Okay, so basically this entire distance around here actually wasn't 17 feet, it was 17 meters. 17 meters long. My unknown value here is the height of the pole. Okay, so I'm going to label the height of the pole with an X. The entire pole is 17 feet long. I can subtract that value of X, and basically this distance over here is going to be 17 minus X. Okay, so notice that the X and the negative X cancel, you add them together, and you get a total sum of 17 meters. Meanwhile, I'm told that the pole hits the ground 10 meters. The end of the pole hits the ground 10 meters away from the base. So you can see what I have right there. This is pretty straightforward as far as coming up with a solution. The key is I've got a right triangle. A little bit of an assumption here, but the pole is vertical originally. And so since I have a right triangle, I should be able to use the Pythagorean theorem. And the key here is getting all three sides labeled with something. Okay, if you can get all three sides labeled with either numbers or preferably the same variable, you're going to be able to come up with the solution. And that's what you can see here. So the Pythagorean theorem says I take a leg squared, okay, in this case that's x squared, plus the other leg squared, which is, of course, 100. And that's going to be equal to the last leg squared, actually, in this case, the hypotenuse squared. All right? Now, you have to be careful here when you do this. This is actually the quantity 17 minus x times the quantity 17 minus x. All right, it's a FOIL problem, so be careful about just trying to distribute an exponent through parentheses. You are going to have to do the distributive property. So basically when I simplify this thing, I end up with x squared plus 100 is equal to, if I multiply this out, 17 squared is 289. It's going to be basically minus the 17x, minus another 17x, it's minus 34x, and then plus x squared. And something really fantastic happens here when you're trying to solve this equation. Notice that I have an x squared on both sides of the equation. So you think that this thing's going to be a quadratic, and then you find out at the end, no, actually not a quadratic. I can subtract x squared from both sides, and we're going to get a little bit of simplifying here. The x squared is canceled. I'm left with 100 equals 289 minus 34x, okay? And I can subtract 289 from both sides here. And we're going to get negative 34x is equal to negative 189, okay? So when we divide both sides by negative 34, of course it's going to end up being a positive. I get 189 over 34 for x. By the way, I believe that's simplified. If you wanted to write this as a mixed number, which really doesn't need to happen, but if you did, 189 breaks up into 5 34s. And leaves me with 19/34 at the end. So again, either answer is okay. This is in meters, so you do want to make sure that you put units there. And I'll just leave it as 189/34 meters. I actually think that's the best answer. So that's the basic idea. Label the three sides of your right triangle. Even if you've got variables on multiple sides, as long as it's the same variable and everything is mathematically accurate, you're going to come up with an answer. So a lot of problems that seem like they're going to be pretty challenging really aren't that bad.